So I welcome you all, and I'll be doing an tutorial on how to model and the analysis of a box culvert, concrete box culvert using SAP 2000. And for this, I'll be using this kind of arrangement, and this is the length of the box culvert. This on this way you have the roads and you have different loadings. I'll be taking only one segment of 5 meters by 6 meters, and the thickness of the roof slab, right, will be around 600 millimeters, and the walls are 450 millimeters, while the base is 700 millimeters. And uh, you will have spring supports for this one, because unlike in if you model it in a pin support, right, so pin doesn't uh, allow you to settle or translate, right? So it's not actually the realistic behavior, because the soils settle when the load is applied. So the F is equals Kx. If your X is uh, uh, in a considerable value, then that means you have considerable stiffness as well, right? But if your X is 0, so that means only possible way is you can have an infinite stiffness. Then the force is divided by stiffness. Uh, so the soil should be then modeled as a finite stiffness element, right? So that means it has some stiffness, and you model it as a spring, right? Spring also have a stiffness, right? If you model it as a pin, that's wrong, because it doesn't allow any settlements, right? Okay, so then you will go to SAP 2000. So again, I will repeat. So I had applied surcharge on the left side and sorry, the right side and the surcharge on the left side. So what you need to do, the change is along the y direction, that is minus. Okay, magnitude is minus, so that it will be applied on the negative y direction, right? And the soil, the load type is soil left, right? So what you did was you select that element, area load, soil left, y, the magnitude is uh, negative, okay, negative 10.6. So I will add the surcharge as well. Oh no, before that, I will apply the soil above. So my soil above is 0.8 meters. So when I select this element and then the density of soil, my soil, the selected soil was around 17.6. So I have 0.8 thickness. So that means 17.6 into 0.8 means around 14, right? So I'll apply that pressure. So that is soil above. That's in global direction. So it's in upward direction, but this is in negative direction. So that means minus 14. Okay, right. And just like that, you have to apply the road above as well. So road is asphalt concrete, so density would be around 22, right? So 22 into point, so point 0.2, right? 0.2 meters is the thickness. The density is 22 kilonewtons per meter cube. So when you multiply, it will be around 4.4. So that is rolled above. Right. So even the surcharge also. So this is the surcharge on the right side. So I had earlier calculated the surcharge value as 7.2. So that's in y direction. Okay, I'll give you the value 7.2 kilonewtons per meter squared global. That's okay. Nice. And done. And for this one, I have already almost selected everything. Yes, I can assign surcharge on the left, y direction negative, right? Because I'm applying, it's a uniform, right? It's a uniform surcharge along the depth, right? So now so I have to save it, right? First you have to save it, right? So I will save it here. Culvert. Okay. So I can replicate. So this is with every loading, right? So I can select this and replicate Control plus R in the X direction. by 0.5 intervals for 11 times, right? That is also 6 meters. Why? The reinforcement comes in 6 meter interval with 6 meter segments, right? Yes, that's done. You can see everything is there. And if you need, you can fill object. Yes. So next thing is you need to apply the HB loading due to the vehicles. So the critical location is like when two wheels. So this is uh, the y direction. Like y direction is the road direction, right? So perpendicular to that, you will have the axles, right? So critical loading is that you will have two wheels just pass the center line, and the spacing between the axles is 1.8 meters, right? So the dispersion means the load distributed area, right? It's about the 1 meter, let's assume, right? So you can always calculate these things according to any code, right? Don't worry. So I'll take the XY plane. Sorry, not the XY. Yeah, it's XY but my grids are not defined, so that you have to go to this view option, right? View, set 2D view, right? So you can choose XZ, right? XY at 5 meters, right? Sorry. So SAP gives you advanced viewing options, right? It's at 5 meters. Okay, set okay. So this is your uh, top view, and not sure there. Let's say this is the 3D view. Okay, so I'll apply. So this is the center line in that case, right? So this is y0. It's going from here to here. X is going from here to here, right? So I'll apply. So the critical is when you have two wheels just past the center line, and load dispersion area is also I'll consider 1 meters. Okay. Okay. And I'll apply this along 4 meters. So that means 0.5, 0.1, 2, 3, 4. Right. Okay. And the other two wheels will be followed after 1.8 meters between center to center. So if you just lose 0.5 and 0.5, that will be 0.8 meters. So that I can safely assume that is 0.5, right? So these are the two wheels, first two wheels, just pass the center line, right? So I'll apply sign area loads, surface pressure, sorry, on the shell. So that's in global set direction, not the surcharge, but HB. So that was around 75 kilonewtons per meters cube, meter squared, right? Squared. So that's the due to the vehicles, right? So you can see the value from the value as well, right? So 75, that's okay, done. Yes, it has been applied. Okay, nice and steady, so that I can choose this entire things, right? Entire, say that is X, sorry, Y Z view. I think I can't see that, right? I need to apply the soil springs, right? So how do I apply is, so I'll go to this view and I need 2D view at where XY plane is set at 0, right? So this is on the soil. As I explained earlier, I have to apply the springs. So the spring constant you can take is, so usually norm is factor of safety times bearing capacity times 40, right? Factor of, so I'll write it, I write that. So you can take this spring constant, right? FOS into bearing capacity into 40, right? So for our case, let's take a factor of safety of 2, bearing capacity, let's assume 100 to 40. So that will give you 8,000. Okay. So kilonewtons per meter cube, as I remember the unit. So you need to apply, multiply by the contact area. So if you have something like this, it's like this. So this element will, sorry, not the element. We are actually assigning at the joints. So this joint will have this tributary area, and so as this, joint, right? I have not drawn it to a scale, that's why, but this element will have only half of that tributary area, right? And this element as this joint as well. Okay, and this will have only a quarter of that tributary area, this joint, right? So we need to multiply by according to that. So this is 0.5, 0.5, like it's our element size. So that will be 0.5 into 0.5. This is half of 0.5 into 0.5, right? So if you multiply this by 0.5 into 0.5, so that will be 2000, right? So you can select these joints and assign joints, springs, global, translation in Z, 1000. Okay. So that's okay, and you can apply. I think you can't see. I'll show the view in black. Yeah. Display. Yeah. For the background, I'll choose black. Yes, you can see the springs, right? For these springs, you will have a value of, we apply the springs at the joint, right? Assign joints, right? So that will be half of this, because the contact area is half of that earlier. It's done. And the corners. Assign springs 500. That's done. I think I have not. Is it? Oh, I haven't, I think. Check elements. Yes, I haven't. Select these jobs. Right. Springs 1000. Okay. Now it's okay, I think. Yes. You can see the spring is there, and you can save it. Control S, or else you can save it from here. Again, think about the structure. Now we have applied the restaurants as well. So any kind of loading, and if you need to apply loading due to traction, right, you can apply this any line, right, apply it in the horizontal direction or the road direction, right? So if you need, right, so but the fundamentally the structure is not stable in the horizontal direction, because we did not restrain anything. So you can select these 2 points, this corner point. Okay, so you have to assign joint, restrain it, translation 1 2, right? Otherwise what is happening is not 3, because we have a spring in the third direction. Now this is stable in horizontal direction, right? Otherwise your answers will not be there, because the structure is unstable, right? The horizontal directions. Now is stable, so we have provide that idealization as well if you need. Now it's turn off creating any load combinations if you need, right? Can add anything from these factors. So the codes will guide you about the factors, gamma, beta, everything, right? The beta is the factor due to arching, right? Because due to the arching actions, your loads can be higher, right? Their recommended values are there. So if so, now I have shown you how to model, right? So you can create your own combinations. And for now, I just run the analysis. I don't need the model. So for now, I'll click the areas local axis. Sorry, I think I need to that, yes. So the local axis, you can see in the first axis is red, right? Second one in this direction, right? So second one is in the road direction, right? Where you have the bendings as well. So this wall will be sagged like this, right? So that will be also bended around. That will be given also by second direction moments, right? M22. So this also will give M22 because it's not like the beam. The axis is, the bending is defined by like this. I'll show you. It's like this. If you have axis 1 and axis 2 for this shell element, so the bending 1 is it's like this, and bending 2 is it's like this, right? So actually the bending M22, this is M22. So this bending moment is actually about the axis 1, right? The direction is like this, right? So if you get the side view, this is the second direction, this is M22. Now you can't see M11 because it's coming from the plane or going in towards the plane, right? So this is given by, it's not like the beam. In the beams, you define if the axis is X, so you take either Y or Z axis to define MY or MZ. So this is totally different, right? So the along the road, the moments will give that sagging or hogging by M22, right? So you can stop. Yes, you can go to SAP, and you don't need now the. It is same for the balls as well. You don't need the local axis. You can run the analysis. Yes, you can check the joints. Let's say I haven't created any combinations. If you need, you can check those, right? So the reactions are there, right? You can see if you need the deform shape for HP loading, you can see the settlements, right? If you apply a basic pin or roller or whatever to this, that is wrong, right? That will restrain the Z direction translation. Even in this point as well, you have a displacement in the vertical direction that will give you the theoretical behavior of soil when a load is applied, right? It will be deformed. So if you want, you can check the bendings as well. Shell element M22, right? So not the dead, but HP. So you can see, right? This part is negative, right? So that will be sagging, right? In this part, you have hogging bending moments. So you have the, if for this case, you have the reinforcement in top part. For this case, reinforcement at the bottom, bottom surface, right? Okay. So, and when you have the combinations, you should be careful. I'll show you why. I'll show you why, because when you take, so if you need, let's check the surcharge. Let's check due to only the surcharge on the left. right? So that will give you some values, right? This just on the left is, I think, this, right? Not sure, right? So on the search soil, right? Let's give some values. Okay, likewise, this is not the correct, the complete analysis, because you have to, this is on the individual loading. You have to create the combinations as you design. So if you have the combinations, you can check the envelope max and envelope min, which will give you the maximum and the minimum. So if you need the maximums, so you take the maximum from the envelope max, right? It's like this. Let's say you have 6 surfaces, and that will give you the expected maximum of the 6 surfaces. That can even be negative value as well, because there can be some surface where only negative values will occur, right? Among that, that will give the lowest negative. So that means the maximum value, right? So if you need the absolute, so the minimum value, so you need to check the envelope minimum, right? From that, you take the minimum values, right? So this will only be open for the combinations, while the combinations are correctly models. Until that, you can't do it. Okay, you can analyze, you can see, right, the values due to the soil, right, the bending moments. If you need, you can right click on the element. It will give the value. So the soil on right, so that will give you some values like this. Did I check soil right or soil left? Oh, I don't remember. Right is this, right? Yeah. Then soil left. Right. So it's completely different, right? So this will be more different with the combinations as well. So you have to analyze all those. This is how you actually idealize a box culvert, right? I hope you can run the analysis and make form your own combinations. Thank you.